chapter 3.
Is this chapter 3? No, we're finishing 2. We might start chapter 3 today, though. We probably will, I think. All right, so what we're going to do is we're going to do chapter 2.7, which is on standard deviation. Okay? Now, I think they give you only one formula. I'm going to give you 2. Okay? The formula they give you is the better one. But we're going to talk about standard deviation. I want you to think of it as the average distance from the mean. In fact, we might do a demonstration here in a minute, but let me finish this. So there's actually, I can't remember, I think the book only has one formula for standard deviation. The one that you're probably going to use is S equals the sum of xi minus x bar squared over n minus 1 square rooted. Okay? That is what we refer to as your sample standard deviation. Okay? That's the better formula, because most of the time we're going to be dealing with samples. On the other hand, there is another formula that I want to show you, and it is very similar. We're going to use the Greek letter sigma. It looks like a 0 with a tail on the front there. Sigma equals the square root of the sum of xi minus mu squared over n. Okay? This is what we call the population standard deviation. Okay? So the idea here is if you're dealing with a population, you're going to use this formula. If you're dealing with a sample, you're going to use this formula.
On that second one, it's xi minus what is that?
The letter mu. It looks like a U with a tail on the front. I write it as mu for mu. Okay? If it looks Greek to you, it is. Okay? We're going to teach you a lot of Greek. So that's the Greek letter mu. This is the Greek letter sigma. And this is also the Greek letter sigma. This means standard deviation. This means sum, typically. Okay? Now, in both cases, in fact, I know students love to write steps to find standard deviation. Okay? So I'm going to write these steps down. I haven't decided yet. I may give you these 2 formulas for your test. I probably will. I probably will. So I'll give you these, but you'll have to memorize the steps if you want to memorize the steps. Okay? But the idea here, the first thing you're going to do is you're going to find the mean, which you've all done since, what, elementary school? Everybody's found, you always call it the average, right? We've got allergies, so I'm going to apologize for coughing too much. Number 2, I want you to find the data, each data point minus the mean. Okay? Number 3, I want you to square the difference. Number 4, I want you to find the sum. And number 5, you're going to divide by n or n minus 1. Now let me ask you a quick question. How do you know when you're supposed to divide by n or n minus 1? Based on whether you're finding the sample or the population. If you're dealing with a sample, you're going to divide by n minus 1. If you're dealing with a population, you're going to divide by n. Okay? And then, oh, by the way, this has a special name. It's called the variance. Okay? If you take my Math 2040 class, you will learn a test called the analysis of variance. Sometimes we like variance. We won't learn that in this class, though. Number 6, take the square root. Okay? Now, I know those are just a bunch. At first, this is a little bit of gobbledygook. I wrote that down because I wanted to, the rest of the time we're going to, not the rest of the time, but we're going to use Excel now. So what I'd like to do is I'd like to do a little bit of a demonstration. Okay? So go ahead and open up Excel. And before we do this, I'd like to do some symbol calculations. You'd probably like that too, right? Okay. Let's say that you want to buy some potatoes and you go to farm A and you go to farm B. Okay. At farm A, the potato weighs 4 ounces and it weighs 6 ounces. Okay. At farm B, the potato weighs 1 ounce and it weighs 9 ounces. Okay. Now, if I asked you to find the mean, I'm going to pick on Robert because I happen to remember his name today. Robert, can you tell me what the mean is of farm A?
5.
5. And the mean of farm B? 5. You didn't even use your calculator. That's awesome. Okay. So if we look at this, the quote unquote average potato size is exactly the same, right? So would you agree with me that it doesn't really matter which farm you buy your potatoes at, right? Who agrees with that? No? The mean's the same. Olivia, I remember your name. Well, which farm would you like to buy?
I would go to farm A just because they're more of like a similar size.
Yeah, they're more of a similar size, right? Now, one of the that's great. Now, let me ask this question: who would prefer farm B? There's usually at least one person. Nobody? Kristen. Okay, you're the gambler, right?
Right.
You're the gambler. Okay, this is the Las Vegas farm. In fact, we'll change this to Las Vegas because you could strike it rich, right? And this is the Idaho farm. Okay. All right. Now, a quick and easy measure of variation would be what we would call the range. Okay. Now, the range, Olivia, you can tell me the range, right? What's the range of potatoes at Idaho? So the range is 4 to 6 for a range of how many ounces? 2 ounces. Okay. Now, I don't remember what the book says, but when you're doing range, I would like to know the endpoints. So you've got potatoes that are 4 to 6 ounces. And then I'm going to pick on JC because I remember your name. Okay. What's the range in Las Vegas? 1 to 9, which is a range of 9 minus 1? Yeah, you know how to do that. 8 ounces. Yeah, I know you know. Okay, it's nice to get picked on first because you get the easy questions. Okay, all right. So a range of 8. Now let me ask you this: if I add another potato in here, let's make this one 5 and this one 5, just so that it doesn't change my mean, right? But it also doesn't change my range. Okay, so range is kind of like this big and dirty. You know, it's not very reactive to changes, right? Okay. So, but that's one measure of dispersion is the range. Okay. But you know, this is a math class, and we got to do something harder than that, right? Okay. So let's say we're going to still try to use some easy numbers for a minute. Let's say that I buy 5 potatoes, 1, 2, 3, 4, and 5. Okay. Nice, easy numbers. And I'm going to pick on Dela because I remember your name. Can you tell me what you think the mean is? No, 7.5, that's more than 5. What's the median? Let me ask you that. The median's 3, so is the mean, actually. The mean is 3. So add them up. So 1 and 2 is 3, and 3 is 6, and 4 is 10, and 5 is 15. Divided by 5 is 3, right? Yeah. Okay. All right, so we got a mean of 3. I'm gonna have to start picking on people. I'll pick on Kristen. I know your name. Okay, so here's what we're gonna do. So when we talk about standard deviation, now I'm not gonna do this big complicated formula because I want to keep this simple for just a little bit longer. We'll get complicated in that. But Kristen, can you tell me what is the difference between 1 and 3? 2? Difference between 2 and 3? 3 and 3? 0. 4 and 3? 1. 5 and 3? 2. Okay, now, I don't want you to do any hard calculations in your head like Dayla tried to do. I just want you to eyeball that. I want you to look in there and I want you to say, what do you think the average, or what's the average distance in that column that I've got highlighted? Probably between 1 and 2, right? So what would you guess? 1.5. Whoops, 1.5. That is going to be our guess. Okay, so conceptually, that's a good guess. And we're going to find out how close the guess is in just a minute. Okay, but yeah, so what I want you to understand here is basically we're looking at this variance here. We guess about 1.5. Okay, and that's you can think of that as what standard deviation is. Okay. Now we're going to do the real thing. Okay. No simple math, no guessing. Here's what we're going to do. We're going to copy this over here. Okay. Now I just want to warn you. This will be a test question. I'm going to put some tests. Did I tell you how our tests are going to work in this class? I better get close to the microphone. Okay, so this is being recorded, so you can't say I didn't tell you. So in about a week or two, I'll let you know over the weekend when we're going to have it. But we're going to do an in-class test. That will be in our regular classroom, not here. And then we're going to do a computer test, which is basically going to be in Excel. Okay. Part of that thing, you're going to have to create histograms. You're going to have to create line graphs, bar graphs, pie graphs. You're going to have to do standard deviation. Okay. All this computer stuff that we've been doing here, you're going to have to do in Excel in the testing center. I'm going to give you unlimited time. Okay. If you want to spend 8 hours on there, you can. Okay. That will not be timed, but you have to get there early to spend 8 hours. Okay? I'll probably give you a couple of days where you can do that. So that'll be in the testing center. I need to schedule that and find out when it's available. So this here that we're about to do is going to be a test question. You are going to need to figure out the standard deviation by hand. Okay? So anyway, let's go ahead and do that. So, let's see. I know it's not, well, maybe I'll write the steps on here. So the first step is, I'm going to pick on Keaton. You're Keaton, aren't you? What does the first step on the board say? Find the mean. Okay, we already found the mean. Okay, so the mean is 3. What's the second step? That was too easy. Each data point minus the mean. Okay? Now, so here's what we're going to do. We're going to press an equals, and I'm going to use the arrow key, and I'm going to arrow over 1. And then notice it fills in that's cell I4, okay? And I'm going to subtract off the mean, okay? Now, I'm going to press enter. 1 minus 3 is -2. Now, when Kristen did this, we didn't worry about negative signs. We're going to worry about them now, okay? Now, you may say, gosh, that was such a nice formula, I want to copy, and I'm going to paste it. Do you remember how to copy, Keaton?
Yeah, Control C.
Control C, how do you paste? Control V. Now, if you're not paying attention here, you may look there. Now, let me ask you a question. Is 2 minus 3 2? Okay, so there's something wrong with my formula. Let me go back here, okay? This first formula here says I4 minus I10, right? The second formula says I5 minus I11. What's in I11? Nothing. So it said 2 minus 0, that is 2. Okay? So this is a really good and easy place to mess up. let me go back to this first one here. Did we talk about absolute references, relative references? Absolute reference, okay? Now notice I put in a $sign there. Okay, absolute reference does not change when copied. And a relative reference changes when copied. Okay? All right, so let's go back to this first thing here. In fact, I'm going to put F4 here. Now, I'm glad we are in this computer lab. When we're not in a computer lab, sometimes people bring Macintoshes in and they don't have an F4. Okay? For the Mac, if you have a Mac, I think you can do Command T. I think that's what it is. But don't quote me. It doesn't matter because you're all going to be using PCs in the testing center. Okay? But for you Mac people, I'm being nice, and I think that's a command. All right, so here's what we're going to do. Okay, so that I4, that's the first number. We want that to be a relative reference. When we copied it down here into the second one, it copied to I5, and we wanted I5 to be the 2. That's correct. However, the I10, we want that number not to change. Okay? So if I press the F4 key on my keyboard, you'll notice that it puts those $signs in there. Okay? So I've just turned I10 into an absolute reference. I want the I10 not to change. I want the I4 to change. Okay? So now when I copy this and when I paste it, it works properly. Now notice here, if you look up in the formula bar, you'll notice up here, the I10 never changes, but the first number changes. Okay, do you see that? Okay, so the I10 is an absolute reference. It does not change. The first number is what we call a relative reference. That changes. Okay? Now, the reason why, if you had 100 data sets, I could have typed 1 minus 3, 2 minus 3, 3 minus 3. I could have done that. But I'm not going to let you use a calculator in the testing center. You can use a calculator on your written test, but you can't use it in the testing center because Excel is the best calculator you'll ever find. Way better than those crap calculators that your teachers used to make you buy. I'm really mad that my son, he's a sophomore in high school now, and they're like, yeah, he has to buy a $100 calculator. And I'm like, that is such a waste of money. You could buy a Chromebook and use Google Sheets for the same price, practically. Calculators are so overpriced, it's ridiculous. So anyway, but I bought it anyway. But I wanted to tell the teacher, you're stupid. Don't force people to buy expensive calculators that are way overpriced. At any rate, okay. So we've got these 5 numbers here, okay? Now I'm going to pick on, in the blue, what's your name? Brock. What does step number 3 say? Square the difference. Well, I don't know why I put that in caps. Okay, so this is your difference column. Now let me just add this. When you're doing your test, and if you can add things like square here, that's going to really help me understand what you're doing. If I understand what you're doing, even if you do it wrong, I'm going to give you more points than if I have no idea what you're doing. Okay? So what we're going to do is we're going to use our arrow keys again. I'm going to click on J4, and then Shift-6, you're going to use that caret key. Okay? And you're going to raise that to the second power. Okay? Now, I forgot. I didn't look at the book. Hopefully, there's enough problems here. I may give you some supplemental problems if there's not enough. I will look at the book after class today. So don't be surprised if I add in some Excel problems and say, here, find the standard deviation. Okay? So -2 squared is 4. Now, let me ask you a question. Do I need to F4 that? No, I do not. Okay? I'm going to copy that. I'm going to paste it down. And I'm going to get that. Now, since I asked you such an easy question, Brock, what's step number 4? Find, whoops, 4. Find the sum. Okay, now do you remember, by the way, I would always recommend that when you're finding a sum, always leave a gap between your data and this. If you don't, sometimes people get their data mixed up with their results and then they mess up the problem, okay? Do you remember, Brock, how to find the sum quickly and easily with Excel? Auto sum, right up here. That's the Greek letter sigma, by the way. And then it asks you if that's what you want to add up. Now, sometimes it'll be wrong and you'll be like, no, I wanted to add this. But in this case, it was correct. That's exactly what I want to add, okay? So I will press enter. I'm gonna, who's next to you? Gentry. What's the next step? 5. Oops. It says divide by either n or n minus 1. Now, how do you decide whether you want to divide by n or n minus 1? Anybody remember? Olivia?
If you're finding the sampler population.
If you're finding the sampler population. Now, I did not specify in this problem. Which one is the sampler population? Which one is more likely to be the answer? Sample, okay? So typically n minus 1, I'll even highlight the n minus 1 in red or something. N minus 1, if you're not sure, n minus 1 is probably the better answer, okay? Now, in this problem, because we're just playing around, I'm going to do them both. Whatever, that's in the way. Okay, I'm going to divide by n, and I'm also going to divide by n minus 1. So I just want to see what the difference is. Okay, so if I take 10 divided by what, Gentry? What's my n in this case? How many data points do I have? 5. So I'm going to divide by 5. And I'm also going to do 10 divided by this one, n minus 1, which in this case is 4. Okay? So I got a 2 and I got a 2.5. Okay? Now, what is this step called? It's called the variance. So this is the population variance, and this is the sample variance. Okay? Does that make sense? And then the last step is Cray. I remembered your name for some reason. Take the square root. Okay? So in this case, this is going to be the population, standard deviation, and this is the sample standard deviation. Okay? Now, Cray, do you have any idea what the square root command is in Excel? What would you guess it would be? How about SQ? Oh, look at that. I just typed it up there. Okay? So if you had a guess, SQRT. So I'm going to double click on this, and it's going to say, what do you want me to take the square root of? SQRT is a command. I will do the 2, and I will do the 2.5, just so that we can compare. Sorry, the 2.5. Okay? Now, Chris guessed that our standard deviation was going to be about 1.5. Now, if we assume this was a population, her guess was pretty close. It's actually 1.41. If we assume it's a sample, it's 1.58. So that was a really good guess, okay? Does that make sense? Okay? I'm not going to get into all the theory behind this. I'm just going to say, trust me, that's the right formula. Okay? Now, on the test, I will have to specify if your data is a population or it's a sample. So let me ask you a question. let's say that on a test, I wanted to find what was the mean score of this class. Okay? Would this class be a population or a sample?
Population.
Would be the population, right? So could I find the population standard deviation for this class? Yes. If I wanted to do a sample, I would pick Robert and Craig and Chris. That would be just 3 people, right? Do you think they would be very representative of the whole class? Kind of a small sample, right? But theoretically, so those 3 could be a sample, and would I divide by n or n minus 1 in that case? N minus 1, okay? Now, the reason why they use n minus 1 is a word called unbiased. Anyway, I won't get into that too much, but that's generally the formula, yes.
Will you explain again how you know what n is?
N is always your sample size.
So that's like how many there are?
How many data points you have. That's exactly what n is. Any other questions on that? Would you like to do a harder problem this time? Okay? All right. So here's what I'm going to do. We're going to open up a new page here. Actually, I should look here. Let me look really quick. I have a feeling I'm going to have to supplement the homework. Let me see here. Or, well, I could maybe. By the way, did you all look at a stem and leaf plot? I think I skipped that last time. We'll cover that again. Those are easy.
Are you going to be posting this on campus?
I'm going to give you some supplemental information, some supplemental homework, okay, in Excel, and I'll even. Should I post the answer? Oh, by the way, before I do that, do you know there's a cheater method in Excel? No, you didn't know that? Would you like to see the cheater method? Okay, here's the deal. How many points on the test is the cheater method going to give you? 0 points. Okay? But just to show you the cheater method, STDEV, look at that. Okay? So here's what I will say. On the test, if you want to check and see if you got the right answer, you can do that. But how many points is it going to be if you only do that? 0 points. What do you think the .P and the .S stands for? Population and sample. So if I did this and I clicked my data, don't you all hate me? Can't use that. Well, you can use it if you want to check it, but that's all. Okay? You can know immediately if you got it right. Now, okay, let me say this. Because my teacher was so mean to me and made me figure out the standard deviation by hand with a calculator and not Excel, see, I'm being nice to you, okay? I know that command is there, and in the future I will let you use it, but not on this test, okay? So just remember that. So, yeah, standard deviation, .s. Why am I making you do this by hand? Because everybody needs to do it by hand at least one time in their life. And then again, then we'll let you use that after that, okay? So let's do this by hand again. And we're going to make up some random numbers, okay? Now, by the way, if you need some random numbers, Excel's it has a command called rand between. And I'm going to pick on, what's your name in the back? Casey, pick a number. 9. And who haven't I picked on? I haven't picked on you. What's your name?
Gage.
Gage. Give me another number that's more than 9. 60. Okay. All right. So we're going to copy that down. And we're going to go down. How many do you want? We're going to go down there. We're going to have 16 data points. Now watch this. Every time I type, those numbers change, right? That's kind of annoying, right? Okay. So here's what you're going to do. you're going to click on this, you're going to right click and you're going to say copy. And then you're going to right click again and you're going to click on the 1, 2, 3. Okay. Now it doesn't say rand between there anymore. It's got actual numbers there. And now when I type, the numbers don't change. Okay. So if you want to just use random numbers, you'll get a different answer than me. Or if you want to copy my numbers so that you get the same, that's fine. I'll let you choose what you want to do. Okay? So, tell me your name. Sydney. What's the first step that you're supposed to do? Find the mean. And you're going to memorize. Are you going to memorize these steps, or are you just going to look at that formula and know what to do? Okay. You'll memorize it. You're welcome to do that. I will give you the formula, but if you look at this and you look at the order of operations, you need to find the mean, then do data minus the mean, then square it, then find the sum, then divide by either n or n minus 1, and then take the square root. Okay? So you can either memorize those steps or you can just look at that, and if you know your order of operations, you should know what to do. Okay, so how do you find the mean? Remember? You can add them up and divide by, or you can use what command? Equals average. Curse Bill Gates when you do that. That's the mean, not the average. Okay? Keaton, you got a question?
Yeah, so how do you keep it from the numbers changing?
How do you keep the numbers changing? If you highlight this, you say copy, and then you click, you paste special, you click on the 1, 2, 3, that says copy the values. Okay? We use that one there. Any other questions? By the way, I don't know if I dare. That phone call, you know what I'm going to be doing on Friday morning? Something none of you want to do. I'm going to have a colonoscopy. Isn't that so much fun? And they're calling me to say, hey, you need to not eat any food today. So I can't eat any food today except for cough drops and water and clear liquids and Jell-O. And I can have popsicles or something stupid. I'm like, so I'm dying hungry today. Anyway, I can't wait until tomorrow's over. So, all right. So the question that we have to ask here, this is just a bunch of fake data. Do you want it to be a sample or a population? Let's make it a population. This is going to be the population of math 1040 quizzes or something. Just to be a little different than last time. Now, which formula are you going to use more often? Sample. But let's just do this for fun. So I've got 16 students in my class. Okay? All right. So find the mean. And Sydney did that. Whose turn haven't I picked on? Have I picked on you yet? I don't think I have. What's the next step?
Now we gotta find the mean for each data.
Okay, we're gonna close scores. We found the mean already. Yeah, the mean's 34.125. Oh, you missed. It says find each data point,
Yeah.
and then you forgot what the rest says.
Mean.
Subtract the mean.
Oh, subtract.
That's a subtract sign.
Okay. That's why I was like.
Data minus the mean. Okay.
Minus.
So if the directions are confusing, make them unconfusing. Okay. So do you remember how to do that?
Yeah.
What do you always start a formula off with?
Equals.
Equals.
And you click on the one you want.
Okay, the first one. Minus.
Subtract it from your mean to the bottom.
My mean. Is there anything else I need to do? F4. Don't forget the F4. Only the second one, not the first one. Okay, we want that mean not to change. Okay? And now what are we going to do?
Copy.
Copy, I say, and paste. Okay? Those look reasonable. I've got some positives and negatives. What's your name in the back? Eddie. Eddie can do it. You need to get one of those hang loose shirts. It'll say Eddie can. All right. Now what?
You square the difference.
Square the difference. Okay, do you remember how to do that?
I believe it's equal.
Equals.
Then it's first number.
The first number there.
And then shift 6.
Shift 6, which is the caret key.
And then
Do I need to F4 any of those? No. Okay. Then what? Copy and paste. You can double click here. By the way, if you learn all the shortcuts, you won't spend 8 hours in the testing center. Okay. Now, what's the next step? I've already picked on Craig. I don't remember. Did I pick on you already? It's time to do it again. Okay. Now what? Find the sum. How do I do that? Tell me your name again. Gage. That's right. I did pick on you. Auto sum button. Is that what I want to add up? Yes. And then, Robert, it's your turn again. What's the next step?
We divide, it'll be by n minus 1.
It's a population, so we divide by n minus 1?
Just n.
Just n. What's my n?
It's going to be 16.
16. So we're going to divide by, I'm glad you said that, divide by 16. What is that step called?
Variance.
Variance, very good. Population variance. And then, Olivia, what's the last step?
You have to take the square root.
That's QRT. Oh, sorry, did I tell you I gave away the command, right? Equals, that's QRT. Only put one equals though. Square root of 125. And that's called the what? Standard deviation. And you want to check it? Do you remember, Dayla, how to check it?
Yeah, you do equals ST.
Which one? Do with the P, because we're using a population this time. Look at that. You are all as smart as a computer. Do you feel smart today? No? I what? No.
I got behind.
You got behind?
I don't know what to do. Do like just really right there.
So you got this number 125?
No.
You didn't get that number. Did you get this number, 2005?
Yes.
You got that number.
That's where I got lost.
That's where you got lost. Okay, so who remembers, here, I'll erase it here. Who remembers what the next step is? So she got the sum.
Do you divide?
She found the sum here. That's step number 4, right?
Yeah.
Divide by either n or n minus 1. Which are we dividing by? N, because we said it was a population. And take this number, and how do you
divide it by
how do you hit divide? Slash. And we're dividing it by? There's 16. Okay, I was waiting for somebody to say 17, and it's not 17, it's 16, because the first line doesn't count, it says scores. That can be really easy. Now, by the way, do you guys remember how to count without counting? Who remembers how to count without counting? Yes. Highlight all of your data here. And when we look over here, and it says count is 16 right there. Isn't that cool? Okay, that's going to come in handy one of these days. Okay, all right, and then do you know what to do next?
Yeah, you check equal and then type in square root.
Right.
Take the square root of the number.
Of that number there. Okay. All right. Do you feel pretty smart today? Who learned something today? I have succeeded. Okay, I have been a success today. Okay, now, will you know it for the test? Who's going to know it for the test? Only 3, 4, 5? Okay. All right. Now, I was looking at Dela, and I could read her mind, and I knew that she was thinking, why do I care what the standard deviation is? Weren't you thinking that? I knew it. See, I am a mind reader. Okay? We're going to start on chapter 3 just a little bit here. And all right. We're gonna fly through these first few sections. If you look in 3.1, remember when we did histograms? Okay? The idea in 3.1 says, well, you can convert a histogram to a bell curve, okay? A normal bell curve. And so that's why we do histograms. We hope that our histogram says we have a bell curve. If it is a bell curve, bell curves are the best kind of data that you can get. And even if it's not a bell curve, sometimes we can still use the normal curve to simulate it. And so that's kind of why, so section 3.1, which I'm going to fly through really quick, says, this is why we did histograms back in chapter 1. We hope that it looks like a bell curve. Section 2 says you can describe them. Oh, actually, this is kind of a big thing. Let me stop sharing for just a minute, okay? Okay, so if you have a distribution that is skewed to the right, okay, this is right skewed, right? Okay, if I have two lines here, okay, and I tell you that one line represents the mean and one line represents the median, which one's which? Here's another way to think of that. You can think of these here, since it's skewed to the right. Think of Michael Jordan, right? He skewed everybody's distribution. What happened to the mean when it was skewed right? The mean was also skewed right. So this number here is going to be your mean. This number is going to be your median. Okay? Your median is the middle point. Okay? So if you have a right skewed distribution, your mean is going to be greater than your median. And if it's skewed left, what do you think is going to happen? The mean is going to be less than the median. Okay? That's a good test question, by the way. Okay? So that's what 3.2 talks about. 3.3 is finally when we start getting into the normal distribution. And then we go to 3.4, which is what I really wanted to talk about today, which is, and this is what we're going to end up with because I'm about out of time. This is going to be the 68, 99, 95, 99.7 rule. Isn't that a great name for a rule? It's also called the empirical rule, if you like that name better, but I actually like the first name. Okay? So, here's why. If you have a normal distribution, okay, a bell-shaped distribution, we're talking about the population, okay? This value here is the Greek letter mu, the U with a tail on the front side of it. That's going to represent your mean, okay? If you go out one standard deviation, so I'm going to put 1 sigma minus 1 sigma here, okay? The 68, 95, 99 rule says that 68% of your data are within 1 standard deviation, okay? So this area here, 68%, okay? This is why we figure out our standard deviation. So the first thing you should do when you get data is you should do a histogram and see if it's normal. If it's normal, then find the standard deviation, and you'll know that 68% of your data are within 1 standard deviation. What percentage of data do you think are within 2 standard deviations? Wow, that's amazing. Isn't that a great name for a rule? You guys guessed that without even me telling you. Number 2, 95% of the data are within 2 standard deviations. And I'll bet that you can guess third one, Brock. 99.7% of your data within 3 standard deviations. Okay? So what if I told you that women are normally distributed with a height of 65 inches and a standard deviation of 2.5 inches. Illustrate the 68, 95, 99.7 rule. Okay? So, according to this, Olivia, what is the mean of how tall are women? You don't know? 65 inches tall. Okay? That makes sense? Okay? Now, the standard deviation is 2.5%. So you would say that 68% of women are how tall? Chris, it must be your turn.
8% of women would be 65 plus and minus.
65 plus and minus 2.5. So 65 plus 2.5 is 67.5, right? And 65 minus 2.5 would be 62.5, okay? So 68% of women are between 62.5 inches to 67.5 inches tall. Okay? Number 2, how tall are 95% of the women, JC?
Sorry, I wasn't listening. I'm sorry. What'd you say?
How tall are 95% of the women? They're another standard deviation away. So what am I going to subtract on this side? 2.5. So 62.5 minus 2.5 is 60. So 95% of women are 60 inches to, what's 2.5 there? That's 67.5 plus 2.5, 70 inches tall. And number 3, tell me your name on the end. Gentry. How tall are 99.7% of women? I'm going to subtract what? 60 minus 60. The standard deviation is 2.5, right? 60 minus 2.5 is 57.5 inches. And I'm going to add 2.5 to here. This is 70 here. That would be 72.5. Okay? So 57.5 inches to 72.5 inches. Does that make sense? Okay, one last question. What percent of women are less than 60 inches tall? Less than 60 inches tall would be here, right? Okay, we know that between 60 and 70 are what percent? We know that that's 95%. So how much is in this tail and this tail? 2.5 for each side, right? So what percent of women are less than 60 inches tall? 2.5%. Okay? All right, so your homework is going to be the rest of chapter 2, and I'm going to add in a few more standard deviation problems in Excel. So I will do that as soon as I can today. And then chapter up to 3.4. Okay? The rest of chapter 2, 2.7 to 3.4. That's the easy way to say that. So your quiz is going to be 2.7 to 3.4. I will not make you do standard deviation by hand.
Are you doing the supplemental Excel questions?
Well, the supplemental Excel questions will be more for the, they won't be for the quiz, but they'll be for the test.
Are you posting those right now?
I will post those as soon as I can. So just check it for that later today. And I'll probably post 4 or 5 problems.
And then how come it's 2.5% are less than 60, not 5?
Because 2.5% are higher and 2.5% are lower.
So
Oh.
2.5% is super tall.
Would you? Yeah, 2.5% are super tall. Yeah.
Are you posting this Excel on?
Yeah, I will post it.
Oh, thank you.
Okay.